Scientists now know that things go bump on Mars on a fairly regular basis, adding to mounting evidence that the red planet is far from. New research has revealed previously undetected quakes beneath the Martian surface, which experts think is proof that it hosts a sea of magma in its mantle. They believe the best explanation for the Marsquakes is ongoing volcanic activity underneath Mars' dusty, barren surface, and believe the planet is more volcanically and seismically active than first thought. For a long time, experts thought that not much was going on inside Mars, but researchers at the Australian National University made their finding after combing through data from NASA's InSight Mars lander. New research has revealed previously undetected quakes beneath the Martian surface, which experts think is proof that it hosts a sea of magma in its mantle. Pictured is an artist's rendition of the InSight lander, which has been taking Mars pulse since landing on the planet in 2018. Using two unconventional techniques, only recently applied to geophysics, experts detected 47 new seismic events coming from a region on Mars called the Cerberus Fossae. Researchers at the Australian National University made their finding after combing through data from NASA's InSight Mars lander. Pictured is the landing site of InSight and waveforms of two Marsquakes. Was Mars ever home to liquid water? Evidence of water on Mars dates back to the Mariner 9 mission, which arrived in 1971. It revealed clues of water erosion in riverbeds and canyons, as well as weather fronts and fogs. Viking orbiters that followed caused a revolution in our ideas about water on Mars by showing how floods broke through dams and carved deep valleys. Mars is currently in the middle of an ice age, and before this study, scientists believed liquid water could not exist on its surface. In June 2013, Curiosity found powerful evidence that water good enough to drink once flowed on Mars. In September of the same year, the first scoop of soil analyzed by Curiosity revealed that fine materials on the surface of the planet contain 2% water by weight. In 2017, scientists provided the best estimates for water on Mars, claiming it once had more liquid H2O than the Arctic Ocean, and the planet kept these oceans for more than 1.5 billion years. The findings suggest there was ample time and water for life on Mars to thrive, but over the last 3.7 billion years the red planet has lost 87% of its water, leaving it barren and dry. Knowing that the Martian mantle is still active is crucial to our understanding of how Mars evolved as a planet, said geophysicist Havoye Takali of the Australian National University in Australia. It can help us answer fundamental questions about the solar system and the state of Mars' core, mantle, and the evolution of its currently lacking magnetic field. Mars has very little in the way of a magnetic field, which suggests a lack of internal activity. Planetary magnetic fields are usually generated inside the planet by something called a dynamo, a rotating, convecting, and electrically conducting fluid that converts kinetic energy into magnetic energy, spinning a magnetic field out into space. Earth's magnetic field protects us from cosmic radiation that could destroy life, but on Mars the radiation levels are much higher despite the planet being further from the Sun. All life on Earth is possible because of the Earth's magnetic field and its ability to shield us from cosmic radiation. So without a magnetic field, life, as we know it, simply wouldn't be possible, Takala said. However, when NASA's InSight lander arrived in November 2018 and started taking Mars pulse, it found that the planet was rumbling. So far it has detected hundreds of Marsquakes, but Takali and his colleague, geophysicist Wei Jia, son of the Chinese Academy of Sciences, wanted to look for quakes that might have gone unnoticed in the InSight data. Using two unconventional techniques, only recently applied to geophysics, the duo detected 47 new seismic events coming from a region on Mars called the Cerberus Fossae. Most of them resemble the waveforms of two Cerberus Fossae quakes that took place in May and July 2019, suggesting that the smaller quakes are related to the larger ones. While looking to establish the cause of the quakes, the researchers discovered that there was no pattern in the timing of them, which ruled out the Martian moon Farbas being of influence. We found that these Marsquakes repeatedly occurred at all times of the Martian day, whereas Marsquakes detected and reported by NASA in the past appeared to have occurred only during the night, when the planet is quieter, Takala said. Since arriving in November 2018, the InSight lander has worked with several missions orbiting Mars and roving around on the planet's surface, including the Curiosity rover. Therefore, we can assume that the movement of molten rock in the Martian mantle is the trigger for these 47 newly detected Marsquakes beneath the Cerberus Fossae region. Previous research into the Cerberus Fossae has already suggested that the region was volcanically active within the last 10 million years. If Mars is more volcanically and seismically active than first thought, as Takali and Sun believe, it would change the way scientists view its past, present and future. The Marsquakes indirectly help us understand whether convection is occurring inside of the planet's interior, and if this convection is happening, which it looks like it is based off our findings, then there must be another mechanism at play that is preventing a magnetic field from developing on Mars, Takala said. Understanding Mars' magnetic field, how it evolved, and at which stage of the planet's history it stopped is obviously important for future missions, and is critical if scientists one day hope to establish human life on Mars. The research has been Nature Communications.